Let's have a look at partial pressure. Imagine this container. We've got a cylinder that has both red particles in it and gray particles. I'm guessing they're trying to model atoms. But if you count them up, there's 10 reds and 6 grays. All pressure is molecules or atoms hitting the walls of a container and exerting force. And each particle exerts an equal amount of force regardless of its identity. Therefore, 10/16 or 5/8 or 62.5% of the pressure will be due to the red particles, the rest due to the gray. I've just explained the basic principle of partial pressure, which is that it's the sum of the partial pressures which creates the total pressure. In this particular cylinder, valve really, we're currently at a pressure of 1 atmosphere according to this. And if we want to know what the partial pressures are, I guess it would be 0.625 atmospheres for the red, 0.375 for the silver. If that makes sense to you, you'll be fine. You don't really need this formula that the partial pressure is due to the moles of a gas divided by the total moles multiplied by the partial pressure, which we just did. Multiplied it by 1 since 1 was the total pressure in that container. Let's do another problem. A mixture of gases has 4.46 moles of neon, 0.7 moles of argon, 2.15 moles of xenon. Figure out the partial pressures of each. Well, we'll add up the total to find the total pressures, and it looks like most of it's going to come from neon. And here's the work that goes into it. We've got 7.35 moles, of which 4.46 are due to neon, so that's going to be more than half of that pressure. Where is the total pressure? 2 atmospheres is the total pressure, so I'm guessing we're going to have 1.2-ish, something like that for the neon. And there it is, 1.21. Did I say 2.1? That's the total, so it would be more than half of the 2 came from the neon, only 0.74 for the argon divided by the 7.35 moles total, so that's looking like, maybe a tenth, and certainly that's about a tenth. And there you go. And when you add all 3, it should come up to the 2.0 atmospheres. That's the total pressure, and those are the partial pressures. So that's a look at partial pressure.